Hi, I am Syed on Maths Online. Today I'll be dealing with the topic Euler's equation. Let us first try to see the statement of the Euler's equation. The necessary condition for this integral I is equals to integral x1 to x2, the function f of x comma y dash into dx, where the condition y of x1 is equals to y1 and y of x2 is equals to y2 to be an extremum is that this partial derivative dou f by dou y minus d by dx of dou f by dou y dash is equals to 0. So this is the condition for an extremum, and this equation is called as Euler's equation. So what does this mean, that the condition that I should be an extremum? For here, the extremum, for an extremum, the given function can either be maxima or the given function can be minima. So we are talking about the function I to be an extremum, which means that I can be either maxima or minima. And for maxima or minima, the condition is that derivative of the given function with respect to some variable. So usually whenever we talk about function y to be an extremum, maximum or minimum, the initial condition that we take is the derivative dy by dx should be equals to 0. That is the first condition for maxima or minima. If y is the function, then dy by dx will be equals to 0. So if I want to say that I is an extremum, then di by dx, depending upon whatever variable we are going to take. As we move further in the derivation, I'll tell you whether you have to take di by dx or some other variable. As of now, the basic condition is that di by dx should be equals to 0. So this variable we'll try to see in this problem, whether we have to take x or some other variable. So that is the basic definition of an extremum. For an extremum, either I is maxima or minima, the condition is that di by whatever the variable that we are taking should be equals to 0. Now let us try to derive this expression and obtain the Euler's equation. So let us start with the proof. Now to obtain this proof, let me first try to take a given curve. So let us consider the x-axis and the y-axis. So let me consider a certain curve. Suppose if I take this as a given curve. Now this curve I am taking it as y of x. That is a given curve. In the neighborhood of this given curve y of x, I will be taking one more curve. So I am taking one more curve. Let this curve be equals to y of x plus h times of alpha of x. So in the neighborhood of y of x, I have taken one more curve, y of x plus h is very small value, into the function alpha of x. So both the curves are between the points. Say let me take this particular point on this is the point P. Let me take this point P to be x1 comma y1, and this point, let me take that to be, it is q of x2 comma y2. So this is the point q that you have. So you have this as x1 So from here to here, from the origin to this point, it is x1. So let me take this as x2. x2 is nothing from the origin to this particular point, it is x2. And this vertical distance is y1 over here, and this vertical distance is y2. So we have got the graph. So this particular value that you have, so let me just extend this to is a straight line. So at this point x, this is your y distance y. So this particular region is nothing but h times of, it is h times of alpha of x. So what we are considering over here, let us take I to be an extremum. Let I be an extremum. I be an extremum along the curve, y is equals to y of x. So this curve at the bottom that you have, y is equals to y of x is the curve. Now this particular curve is passing through the points it is p of x1 comma y1, it is x1 comma y1, and it is q of x2 comma y2. Those are the 2 points you can see in the figure. Then let us take the given function y to be equals to that given curve. Y is equals to, it is y of x, so we are considering a neighboring curve, y of x plus h times of alpha of x. The second curve on the top in the figure represents y of x plus h times of alpha of x. So let us take this as equation number 1. So equation 1 is nothing but this particular curve, y of x plus h into alpha of x. Let me differentiate this with respect to x. So if I try to differentiate this with respect to x, I'll be getting the value to be equals to y dash is equals to, on the right hand side, derivative of y of x will be y dash of x plus h, however, is a constant over here, it will remain as it is. Differentiation of alpha of x will be alpha dash of x. Let us take this as equation number 2. So from the figure, if you try to observe, at the point p of x1 comma y1, what will be the value of alpha of x1 value? Alpha of x1 at the point p. So at this particular point p, this particular point, what is the value of alpha? This particular value of alpha. So alpha of x1, its value will be equals to 0 because both the curves are coinciding each other. Therefore, its value will be equals to 0 at the point it is p of x1 comma y1. In the same way, if you consider alpha of x2 at the point q, there also its value will be equals to 0. x2 comma y2. So at this particular point, you can see over here, at this particular point, both the curves are coinciding. Therefore, alpha of x2 value will be equals to 0. Now suppose if I take the value of h to be equals to 0, suppose if h is equals to 0. So suppose if I am taking h to be equals to 0 over here. So h is equals to 0, this particular expression, if I take h is to be equals to 0 and put back the value of h is equals to 0 in equation number 1. So this equation number 1 will imply y is equals to y of x, which is the original curve. So which means this particular curve will coincide with the original curve. So the curve y of x plus h into alpha of x will coincide with y of x. So both the curves will become the same when the value of h is equals to 0. So when both the curves are the same, then I will be an extremum. If h is equals to 0, then thus the value of I will become an extremum. So let me write down in the form of the statement. If h is equals to 0, the two curves coincides each other. The two curves coincide each other, so thus making I an extremum. So I will become an extremum when both the curves coincide each other. So in that case, the value of I will be equals to, so let me write down the value of I. So your value of I will be equals to, it is integral of x1 to x2. So we get the function f of, it is x comma, the function equation number 1 we can write it as y of x plus h into alpha of x. Then y dash value you have, so therefore we'll be getting y dash of x plus h into alpha dash of x times of dx. How is that we are going to write in this form? Because in the statement I have already mentioned that the function can be written as f of x comma y dash into dx, which is integral of x1 to x2. I have got I to be equals to integral x1 to x2 f of x comma y dash. So x I have written as it is. In place of this y of x, I have mentioned this by equation number 1. So y dash I have written from equation number 2. I have just plugged in those values over here. So this particular value I is an extremum. When it is an extremum, when the value of h is equals to 0. Is an extremum when the value of h is equals to 0, because both the curves will coincide each other. So as I told you initially itself, I told you earlier itself, for an extremum you have the condition, that is di by this condition, di by dx to be equals to 0. However, I told you independent variable will change. So here, because h is equals to 0, therefore di by dh should be equals to 0 for an extremum. Therefore, if I try to rewrite that one, the condition for an extremum, thus for an extremum we have di by dh should be equals to 0 when the value of h is equals to 0. So here I am treating the value of I as a function of h. If that is the case, I need to differentiate the above equation. So let us try to differentiate this with respect to h. So if I differentiate this particular equation, I is equals to with respect to h. So I will be getting di by dh is equals to. Now you have the integral, we'll keep this integral as it is, x1 to x2. So because we are differentiating under the integral sign, so we'll use the partial derivative dou by dou h of the entire function. So this function I'll write it as it is, x comma, it is y of x plus h into alpha of x, then y dash of x plus h into alpha dash of x. It is times of dx. So because I need to differentiate this under the integral sign, there are different variables like x, y and y dash. Therefore, I'll try to apply the chain rule. Apply the chain rule. So let us try to apply the chain rule. So this di by dh will remain as it is. It is di by dh is equals to, it is integral of x1 to x2. So now let us apply the chain rule. So differentiate this f with respect to, what is the first variable you have? You have the first variable as x. So therefore it's dou f by dou x. And further, this x has to be differentiated with respect to h. Dou x by dou h. This particular value. Plus the next variable that you have is the variable y. So if I try to differentiate this one, function f is being differentiated with respect to y, and further y is being differentiated with respect to h. Next variable that you have is y dash. So differentiate this f with respect to y dash, and this y dash is being differentiated with respect to h. So all expression are being differentiated with respect to h. It is times of, you have dx. But if you try to observe h value, h is independent of x. So since h is a small increment that I have given, h is independent of x. This is independent of x because it's just a small increment that I have given to create the curve. So since it is independent of x, what will happen to this dou x by dou h value? Its value will become equals to 0. So dou x by dou h will become equals to 0. So one of the value I have obtained. Now the next value I need to obtain is, I need to obtain the value of dou y by dou h. What will be this particular value of dou y by dou h? We have the value of y from equation number 1. So we'll try to differentiate equation number 1. So you can remember that equation number 1 that you have is, so just try to rewrite that equation number 1. You can remember that equation 1 is nothing but y is equals to y of x plus h into alpha of x. You can just observe equation number 1. This is the equation number 1 I have obtained. So now if I try to differentiate that equation number 1, so differentiate, so I'm just writing in short, differentiate equation number 1 with respect to h. With respect to h I'm differentiating. Therefore we'll be getting dou y by dou h is equals to, because I'm differentiating with respect to h, y of x is a constant, therefore its derivative will be 0, plus derivative of h with respect to h will be 1 into this alpha of x will remain as it is. Therefore if you try to rewrite the value, dou y by dou h will be equals to 1 times of alpha of x will be alpha of x. So you obtained the value of dou y by dou h. Then we need to obtain the value of dou y dash by dou h. If you go back to equation number 2, equation number 2 is nothing but y dash is equals to y dash of x plus h into alpha dash of x. This is your equation number 2. You can just go back and refer to equation number 2. So now I'll try to differentiate that with respect to h. So if I differentiate equation number 2, differentiate equation number 2 with respect to h. With respect to h. So it becomes dou y dash by dou h is equals to. So this particular equation you have. So what will be this y dash value? Because it is a constant with respect to h, its value will be equals to 0, plus derivative of h with respect to h will be 1 into alpha dash of x. So if we try to rewrite this one, this becomes dou y dash by dou h will be equals to alpha dash of x. So these two values I'll try to plug in back over here in this particular equation. So if I substitute there, I'll be getting the expression to be equals to, so I need to plug in back over here in this equation. Let me take this as some equation number. maybe equation number 3. So let us take this as equation number 3. So equation 3 will imply, equation number 3 will imply, so we have di by dh as it is, di by dh is equals to, you have integral of x1 to x2. So first, because dou x by dou h is 0, so 0 times of dou f by dou x, the first term will become equals to 0, plus the second term, it is dou f by dou y as it is. We have got the value of dou y by dou h. What is dou y by dou h we have obtained just now over here? It is alpha of x, plus you have dou f by dou y dash as it is, into, we obtain the value of dou y dash by dou h to be equals to alpha dash of x. So all the values have been plugged in, times of, you have dx. Now further let us try to simplify this one. If I try to rewrite this one, it is di by dh is equals to, it is integral of x1 to x2, this is dou f by dou y into alpha of x, plus dou f by dou y dash into alpha dash of x, just ignoring that 0 value, times of dx. So let us take this as some equation number, say equation number 4. So now I'll keep the first term as it is. So rewriting the equation as, it is di by dh is equals to, it is integral of x1 to x2 dou f by dou y into alpha of x, just multiply that by dx. So applying the integral for the first term as well as for the second term separately, plus apply the integral for the second one. So x1 to x2, you have dou f by dou y dash into alpha dash of x times of dx. So we just applied the integral for both the terms. So now keeping the first integral as it is, I'll try to integrate the second one. So if I want to integrate the second one, I'll try to use integration by parts. So if I try to integrate this by parts, we know the basic formula for integration by parts is u into v dash dx will be equals to, it is u into v minus of integral of v into du. Alright, that is a basic formula for integration by parts. So now if I try to rewrite this expression, I'll be taking this the first expression to be equals to, this is u value, and this value will be taken as v dash. Alright, so it is u into v dash. So suppose if I am taking the value of u to be equals to, say dou f by dou y dash, I am taking the value of v dash to be equals to alpha dash of x. So I need to differentiate the first expression. So if I try to differentiate the first expression, I'll be getting the value to be equal. So let's try to differentiate its du. So if I try to differentiate, so du will be equals to, so I need to differentiate this with respect to x. So it becomes d by dx of, it becomes d by dx of dou f by dou y dash. So I'm differentiating this with respect to x, and over here I need to integrate it. So if I try to integrate this with respect to x, so I'll be getting v to be equals to, the integration of alpha dash of x will be alpha of x So now if I try to use the formula, keeping the first term as it is, over here this first term will remain as it is. It is x12, x2, it is dou f by dou y into alpha of x into dx. This is plus. Now let us use the formula. The formula is u into v. So u value over here is dou f by dou y dash, u into v. So v value is nothing but alpha of x, u into v, minus integral of v into du. V value is alpha of x into du value is d by dx of dou f by dou y dash. Dou f by dou y dash into dx. So here into dx you have. Alright. So I have to close the bracket over here. So this will close the bracket. And the integral limit is nothing but x1 to x2. So here also you have the limits to be equals to, in this case also you have the limits to be equals to x1 to x2. So I need to apply the upper and lower limit values for this one. So this will be equals to integral of x1 to x2, it is dou f by dou y into alpha of x times of dx plus. Now suppose if I want to apply the upper and lower limit value in this case will be alpha of x2. So let's apply the upper limit value. This is dou f by dou y dash into the upper limit value in this case will be equals to alpha of x2 upper limit value minus the lower limit value. Once again this dou f by dou y dash will be as it is. Applying the lower limit, alpha of x value will be x1. Upper limit minus of lower limit minus. Now here I can write down the integral to be equals to, it is integral of x1 to x2. This will be as it is, alpha of x into, it is d by dx of dou f by dou y dash, dou f by dou y dash into dx. But initially itself we have seen that alpha of x1 value at the point P, alpha of x1 is 0, and at the point Q we have seen that alpha of x2 is equals to 0. So these two values we already know. So we'll try to plug in these two values back in the above equation. So if I plug in that back in the above equation, I will be getting the expression to be equals to, this is di by dh is equals to, it is integral of x1 to x2, it is dou f by dou y into alpha of x into dx plus, here alpha of x2 is 0, therefore the first term will be 0. Here the next term will also be 0. Then minus of, you have integral of x1 to x2, it is alpha of x into d by dx of dou f by dou y dash into dx. Or further, if I try to apply the common integral for both, so in that case I can rewrite this as integral of x1 to x2, because alpha of x is common in this integral as well as in the second integral. So I'll be taking alpha of x as common. So we'll be left out with dou f by dou y, negative sign is there, minus d by dx of dou f by dou y dash, right, that's the expression, times of, you have alpha of x is common for both, into you have dx, that's the expression. But further if you try to observe, we have seen for an extremum the value of di by dh will be equals to 0 at the point h is equals to 0. So we know this value earlier itself. We have seen that di by dh dH is equals to 0 when the value of h is equals to 0. So this condition is for I to be an extremum, So initially itself I have given this particular condition. So now here on the left hand side, which you have, it is di by dh. This value will be equals to 0. So when this value will be equals to 0? So this value will be equals to 0 only when this particular integrand is equals to 0. So because the integral of 0 gives rise to the left hand side 0 value. So therefore the integrand should be equals to 0. So this particular value, dou f by dou y minus d by dx of dou f by dou y dash, this value should be equals to 0. So this particular equation represents the Euler's equation. Now this is nothing but the Euler's equation. This is the required Euler's equation. Required Euler's equation. So hence we have proved the Euler's equation. So that's all I have for today. Thank you.